Welcome back to day 2 of slope. Today we're going to do the word problems with slope and finding the average rate of change. The average rate of change makes more sense when we're talking about a word problem than does the word slope. We're also going to talk about the y-intercept. And remember, the y-intercept is what the starting point is for your word problem. For example, if I was running a race, the starting point would be the starting line of a race. So our first example, Tony is driving at a rate of 50 miles per hour away from home. So our story is about Tony. His average rate of change is identified by the quantity showing the change of the given situation. In this case, the 50 miles per hour is representing that change. That is talking about the slope. So here the slope is representing 50. And this is a positive 50 because we are increasing up to 50. It's not negative because I can't be slowing down. So the slope in this case is 50. My starting point is the y-intercept. And in this case, where did we start? Tony is going away from home, so his starting point was home. So home is representing my starting point, and that is assumed to be 0 miles into the trip. So therefore, my y-intercept is the point 0, 0. An intercept is always in an ordered pair, x comma y. All right, our next example. Excuse me. Identify the slope and y-intercept of the given description. Bethany is 17 years old and has $4,000 in her savings account. Every year since her 5th birthday, she has added $150 to her account. So the very first thing we want to do is find the average rate of change. So how much did her account change in any particular given year? Well, since her 5th birthday, she has added $150 to her account. So since she is adding, we're increasing her account by $150. So my average rate of change is my slope. So my slope I'm adding, so that's a positive 150. So $150 per year. Now to find my starting point, to find my y-intercept. I don't know how much her account started with when it had first opened. They don't give us that information. So in this case, we need to calculate that information. We just know that she's 17 years old and she has $4,000 in her account. We know her account began when she was 5 years old. So how much did it open with? So let's see. If we've increased or added $150 into her account every year since she was 5 years old and she is currently 17 years old, that means since her 5th birthday, 17 minus 5 would tell me it has been 12 years that they have been adding $150 into her account. So 150 times 12 means they have added $1,800 into the account. Notice that the years here would cancel out, leaving only the dollars to be the amount that has been added. So now to work backwards to find out how much money is left in the or starting in the account. I'm sorry. So we have $4,000 in the account currently. We have increased the account by $1,800. So when I subtract those, that means there was originally $2,200 in her account. So my y-intercept, we started with $2,200. So my time element was 0, my original time, and we have $2,200. So 0, 2,200 for the y-intercept. So those are our 2 examples. It would be a good idea to pause the video and try the 2 examples on the bottom on your own. All right, let's take a look at those 2 examples. Tessa is 3 hours into her trip. She currently has 12 gallons of gas in her car. The amount of gas in the tank has been decreasing at a rate of 2 gallons per hour. So we are to find the slope, the average rate of change, and the y-intercept. So my slope, when I take a look at my problem, okay, we're looking at how much gas has been decreasing out of her tank. So here we have been decreasing at 2 gallons per hour. So my slope has to be represented by a -2 because we are decreasing 2 gallons per hour for my average rate of change. How much gas was in her car at the beginning for the y-intercept? Well, she currently has 12 gallons. She's 3 hours into her trip. So for 3 hours, she was using 2 gallons of gas for each of those hours. So that's a total of 6 gallons of gas, plus the original 12 gallons of gas that were in her car. So that means she started with 12 gallons of gas in her car. So my y-intercept at time 0, she began with 18 gallons of gas. Okay. And the second and last example, Steve started with $1,400 in his checking account on his 12th birthday. On his 16th birthday, he has $800. Assume Steve spends the same amount each year. So they tell us what he has started with. So they tell us the y-intercept directly as $0, $1,400. So our job is to now figure out what is the slope or the average rate of change. So in order to do this, I'm going to write some ordered pairs. So on his 12th birthday, I'm going to call this time 0. That's my starting point for my y-intercept. So that means on his 16th birthday, which would mean an increase of 4 years later, he now has $800. So I'm going to write them as ordered pairs. And now from our last lesson, we know how to find the slope or my average rate of change given 2 points. I find the change in the y's, 800 minus 1,400, over the change in the x's, 4 minus 0. So 800 minus 400 is -600. 4 minus 0 is 4, which will give me -150. So my slope is -150, which means that he is spending $150 per year. So that is a -$150 per year. All right, that's it.